This video focuses on analysis of variance. A public health policy researcher wants to know if the cost of dental treatment varies by geographic region. A t-test is not appropriate because there are more than two groups. The statistical test used when there are more than two independent means is called analysis of variance, or ANOVA. You may also see this reported as a one-way ANOVA, which means that there is one categorical independent variable, in this case, geographic region. The null hypothesis states that there is no difference in mean cost of treatment across geographic regions, or that the means are all equal. The null hypothesis would be rejected if there were mean differences found between any two regions. So the research hypothesis is that there is a mean difference somewhere, that at least one pair of means differs. One-way ANOVA can be thought of as an extension of the independent t-test. Here's the independent t-test example of bond strength for two different cementing agents. If we add one or more groups, it becomes a one-way ANOVA. The null hypothesis is that the mean bond strength is the same for all three cements. And the research hypothesis is that at least one pair of means differs. ANOVA results tell us whether there's a mean difference, but they don't tell us where. If the null hypothesis is rejected, the researcher must do follow-up tests called multiple comparisons to see which groups are statistically different. Here's what ANOVA results might look like for this three-group bond strength example. The researcher reports a statistically significant result, which means that there is a difference in bond strength between at least two of the cementing agents. The statistics that support this statement appear at the end of the sentence. The letter F indicates that this was an analysis of variance. For ANOVA, there are two numbers that represent degrees of freedom. The first number is called the between groups degrees of freedom, and it is always equal to the number of groups minus 1. This is equal to 2 because there are three groups being studied. The second number is called the within groups degrees of freedom, and it's always equal to the total sample size minus the number of groups. There are three groups, so if we add that to this number, we get the total sample size of 15. The next number is the calculated value for F. The p-value is small, so the researcher rejects the null hypothesis. This is what the distribution of all possible values for F looks like when the null hypothesis is true. It has a different shape than the t-distribution, and the rejection region is always in the upper tail. The p-value is the area beyond the calculated test value. Suppose that follow-up test results indicate that bond strength for sp is significantly higher than Z' and U bond, and that there is no statistically significant difference between Z' and U bond. It is also common to see these results reported in a table like this, with a notation indicating which means are not different. Let's return to the example of cost of treatment by geographic region. This statement indicates that the researcher did not find any significant difference in mean cost of treatment by geographic region. There were 7 regions, so the between groups degrees of freedom is 6. The within groups degrees of freedom is equal to the total sample size minus the number of groups, so if we add 7 to 63, we get the total sample size of 70. The calculated value for F is 1.58, and the p-value is large. So the researcher did not reject the null hypothesis. The null hypothesis was not rejected, so the analysis stops at the ANOVA. No follow-up tests are done. To summarize, a test of more than two independent means is called analysis of variance, or ANOVA. ANOVA tells us whether there is a difference among means, but it does not tell us where the differences are. If the null hypothesis is rejected, follow-up tests must be done to determine the specific group differences.